All right, chemists, in this video, we're looking at the decomposition reaction. So in this video, you will learn how to identify a decomposition reaction and how to predict the products of that decomposition reaction. So you'll know you're successful when you can determine if an equation is a decomposition reaction and when you can predict its products. So decomposition reactions, or more affectionately termed decomp, is when you have one reactant and multiple products. Now you might be thinking that looks kind of familiar. Well, that's because this is the opposite of a synthesis reaction, which has multiple reactants and one product. This might give you a little bit better of an idea of that. So for decomp, you have one reactant here that will yield, remember that's what we call this arrow, yield, multiple products. This one has two, you can have more than two. I'm just giving you an example here. But if you remember your synthesis reactions, you have multiple reactants and one product. So it's actually turning this arrow around. Synthesis and decomposition are opposites of each other. In synthesis, you put things together to create one product. In decomposition, your one reactant breaks apart into multiple things. A couple examples here, we have water decomposing into hydrogen gas and oxygen gas, and ferric hydroxide decomposing into ferric oxide and water. In decomposition reactions specifically, you're probably going to see something written on top of the arrow. This is some form of energy that is being added to the reaction to break this bond and create the multiple products, to decompose the original reactant to create the multiple products. So this is not a reactant itself, it's just a form of energy that's being added in order to move the process along. And in this case, we have electricity being added. Here, this triangle, it's actually the Greek letter delta, and it means that heat has been added. So energy in the form of heat. Predicting products for a decomp reaction, the major tool you're going to need is your diatomic elements. Now, depending on how the question is phrased, you might need to remember your crisscross methods, but that's really if it's already giving you the products and asking for the reactant. But generally in this class, you're going to be predicting the actual product. You'll be given the reactant, so that crisscross won't actually be heavily used for these, but knowing it will help. So here's our first example. We have mercury and oxygen. This is mercuric oxide. So remember, we want to break this apart. So we have one thing here. Let's break these into two pieces. We have mercury and oxygen. Here's where you really need to remember those diatomic elements. Any of your metals, they're not diatomic. They can stand on their own. You've heard of mercury by itself. You've got gold and silver and nickel and copper and zinc. All of these things stand on their own. Even metals like potassium and sodium and calcium. All of those can stand by themselves. So we actually don't need to write anything more. It's just mercury, period. Oxygen, however, is one of our 7 diatomic elements you should remember. So we're going to throw a 2 in here because it cannot exist by itself. It must be bonded to at least one other atom, in this case, another atom of oxygen, creating oxygen gas. Now here we do have an unbalanced equation. So throw in a 2 here to give us, we have 2 oxygens. Now we have 2 mercuries, balance it here. And there we go. There is your final balanced equation for the decomposition of mercuric oxide. If you are still unsure about balancing equations, there was a previous video going over that. Please review it because we will be balancing for the rest of the year. Here is another example for you. Why don't you go ahead and pause this video, try it for yourself, and then we'll walk through it together. Okay, hopefully you paused and are now ready for the answer. We have copper and sulfur here. This is actually, if you were going to say it out loud, copper to sulfide. Copper being a transition metal, you do need to say what its oxidation state is or what its charge is. So we have copper. It can stand by itself. It's a metal. It's a normal metal. We have sulfur, which again, you've heard of by itself. It is not a diatomic. It can stand alone. Copper plus sulfur. The end. That's it. That's the whole balanced equation, even because we have one copper on each side and one sulfur on each side. So we don't even have to do any work to balance it. It balances itself. So now that you've had a little bit of a taste of these decomp reactions, go ahead and try at least one of these levels, if not all three. Pause the video and then come back and I will show you the answers. There are your answers. So in this video, we identified decomposition reactions with one reactant and multiple products. And then we predicted those products by breaking down whatever the reactant was that we were given. If you've got questions, you know where to find me. Good luck with decomposing things.